10, 15, 20. All right. And we have our objectives for systems of inequalities. We have I'm learning to graph systems of the linear inequalities, and I'm learning to find solutions for inequalities. So we have systems of inequalities. Think about systems of equations. How many lines did we have per graph on our test on Monday? Two. So if we're doing systems of inequalities, how many inequalities are we going to have? Two. So we're going to have two or more inequalities graphed together.
Can we just put graph together?
Yeah. So have two or more inequalities graphed together. Solutions to systems.
But how would you be able to tell it like that?
So solutions to systems. Alright, so your solution to systems of inequalities, said that wrong, inequalities, not equations, is just going to be the region that both are shaded. And one way to kind of look at it is like where they overlap. Because your one inequality will be shaded, your second inequality will be shaded, and you want that shared region where they're both shaded. Okay. So we have three columns: our inequalities, our line type, and where to shade. Because inequalities are going to affect how we make our lines today. So our first one is y. Then the inequality symbol points to the y. So do you want to remember what it is if it points to the y? Less than, you got it. So the inequality just means it's less than. Alright. Now, does less than include your answer? Like if you were to have y is less than 2, does that include it? No. So that means we're going to have a dashed line or a dotted line, however you like to say it. I say dash, some teachers say dotted. This can be a dashed line because it does not include the line. Now, with the shading. Shading's always in reference to our y-axis because it starts off with y. So how does our y-axis run? Up and down. So if you think about your y-axis running up and down, where's going to be less than? Up or down? Down, because less than is going to be down. So we're going to shade below the line or down, however you like to say it. Our second one here says y, and it has the same type of symbol, but now it's a line under it. So what does that say? You got it, less than or equal to. Apparently did not make my line long enough. Alright, so now if it's equal to it, and we are going to include the number. Does anybody remember what type of line we get? Solid, you got it. Solid line. And it's still less than, so where are we going to shade? Still below or down, however you like to say it, underneath. Over the years I've heard people say a lot of different things, whatever way makes your brain happy. So y is greater than, so greater than.
And this would be the dash line?
You got it, dash line, because it's not equal to it. And now because it's greater, and you think about your y-axis, where's greater going to be, up or down? You got it, above, up. So above or up, however you like to say it. And we got greater than, which means our next one's going to be y is what? Greater than or equal to. Alright. So now that we're equal to it again, what type of line are we going to have? Solid, very good. And we're greater than, so where are we going to shade? Above it or up? Once again, however you prefer to say it. and we're all good. So if you have x, and it can be any symbol, less than or equal to, greater than, or equal to apparently or greater than. If it's x with any of those variables, or sorry, with any of those inequality symbols, you still do the line top like you would above. So if it's, you know, less than or greater than, it's going to be dashed. And if it's less than or equal to or greater than or equal to, it's going to be solid. So that part doesn't change. We still use the same line top we would use for y. If it equals to it, solid. If it doesn't equal to it, dashed. Now the difference is how does your x-axis run? Horizontally. So it runs left and right. So if you think about it, where's going to be your less than on your x-axis? To the left, because it rhymes less than is left, which means to the right is greater. Fun fact, if it points to the left, it means less. If it points to the right, it's greater than. So you can shade the direction it points. So shade, direction, symbol points. So how to graph linear inequalities is going to be very similar, there we go, to how to graph linear equations. So if you're looking at how to graph an equation, what was the first step we had on the test on Monday? We're going to graph the line on a coordinate plane. What was step one? Huh? Alright, before I start plotting my points, because that's the first thing we do. Alright, we plot the point first, we have our slope. But what do we have to do before we can even have our slope and our point? We have to solve it for y. We have to get it into what form? We have to write it as y equals mx plus b. So write inequality in slope intercept form, which is your y equals mx plus b. Slope intercept form, y equals mx plus b. Then basically, to piggyback on what you all told me, we're still going to have to find our m, find our b. So find m, and m was our what? Slope, and b, line intercept. Very good. Alright. So once you have both inequalities in your slope intercept form, you find their m, you find your b, you start to graph it. So after you plot, after plotting all the points, after plotting the point, now after we plot the points on a normal equation, so after plotting points, we would normally make our lines with arrows on both ends, move on to the next one. Today we're going to have something different. What's the first thing we have to decide? You got what the inequality symbol is going to tell us, that it's going to be less than or equal to, greater than or equal to. So what's that going to do to my line? Put that piece down for me, sir. So think about it. What will our inequality do to our line? Look up to the table we just made. What is the inequality going to do to our line? You guys are going to tell us which way to shade. It's also going to tell us solid or dashed line. So after plotting points, determine if solid or dashed lines. Okay? You figure out what line you want. You realize it's supposed to be dashed lines. You make dashed lines. What are you going to have to decide after that?
Shade,
You got it. Determine where to shade. You determine where to shade and shade it. So you shade above if it's greater than, shade below if it's less than. And now you have both your inequalities graphed. You have both of them shaded on your coordinate plane. What do you think our very last thing is going to be to do? You got it. Find your solution region. So find solution region. And shade in dark, because we want it really dark. Alright, once again, you don't have to write this one out, but just kind of look here with me. So it gives us two inequalities already. It gives us this line here that's dashed with blue above it. It gives us this solid line here with yellow below it, and blue and yellow make green. So where do you think our solution region is? You got it, where it's green out here. So this is our solution region. It says determine which of the following ordered pairs represent a solution of the system of inequalities graphed at the right. So A is 3, 1. So where does 3, 1 send you graphing? If here's the origin. You got right 3 up 1. Is that one a solution?
yes.
Yes. Why is it a solution?
It's in the shade right here.
You got it, because it's in the green area. Alright, B is -1, -3, so where's that send me? You got, so it's in the yellow. Is that one a solution? No, because it's not in the green where they both are. Alright, our next one is 2, 3. So where's 2, 3 send me? Alright, so go right 2, up 3. That puts me on a solid line. Is that one a solution? Yes. Why is that one a solution? You got, because it's equal to it, which means it includes it, which means it is a solution. Our next one's 4, -2. So that's right 4, down 2. Is that one a solution? Yes, because it's in the green area. Alright, 3, -2. This one's my favorite one. So 3, -2 sends me right 3, down 2. Oh no, I lost my marker. Right 3, down 2. It's on the dashed line. Is that one a solution? No, why not? It's not included, it's not equal to it. And then the last one's 1, 4. So we go right 1, up 4. Yeah, it's in the blue. Does that count? No, so no. Start graphing then. So example 1. I'm going to kind of make this really bigger and just make my own coordinate plane, because my coordinate plane here is a little blurry. There we go. So we have solved the systems by graphing. There we go. So example 1. I always unstack them when I write them, just because where it's graphing, if I need to get it in slope-intercept form, I have space to do that. But here's the good thing. What do you know about these two inequalities? They're already in slope-intercept form. They already look like that y equals mx plus b. So the only thing we have to do then is find our m and our b and graph them. So for this first one here, I'll make it purple. What's his m going to be?
You want -1 over 1.
You got -1 over 1, because there's a -1 here in front of the x. And where are we going to begin? Where's their b? Where's it going to begin?
0,
0, 1. There we go. And now I'll go ahead and make my coordinate plane and get that started. So I'm just make a baby coordinate plane, 5 in every direction. Got x, y, and then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Perfect. Alrighty, to graph them, we will begin with B. So where does B send me in my coordinate plane? You got it, 0 and up 1. And now my slope is -1 over 1. So where does that send me? You got down 1, right 1, down 1, right 1, down 1, right 1, as many as you want to make. Now, I know if this were an equation, we would make our line and we would move on. However, it's an inequality. So we have to go back here to our symbol and say if y is having the inequality symbol point to him, that means y is what? Less than. So if y is less than, what type of line do I need if it's less than? Dash, because it's not equal to it. And now I'm just going to make a dashed line over here. There's many ways to make a dashed line. You can, like I do, and just kind of dot it out. You can also make a solid line and then go back through with your eraser and make like little marks in it to make it, oh, that wasn't a very good example, to make it look like it's been dashed. There we go. Oh. So a couple of different ways to do it. Now, I'm still not done. What's the last thing we got to do with it? Shade it. So if it's, once again, y is less than, where am I going to shade for less than? Below it. You got it. Now, I always like to think about our y-axis. So there's our y. Is below going to be up or down? Down. So I'm going to take it this way. Turn your pencil like this and really, really lightly shade it up and down below this line. So that line is our boundary line. We can't cross it. We got to shade everywhere below it. And if you notice, I go all the way across my coordinate plane. I shade in the whole coordinate plane, all the way across there with that first inequality. And now we have it graphed. Second inequality, we'll make blue. So blue. So what's his m going to be? 2 over 1. You got it. And where's he going to be, Ken?
3.
0, 3. You got it. So remember, we're going to begin with B. And this is why we want to shade really, really lightly, because now I'm going to have to graph this on the same coordinate plane. So I'm going to go to 0, then up 3. 1, 2, 3. And where's my slope send me? 2 over 1 sends me. You got up 2, right 1. And then if I can't go up 2, right 1 anymore, I can go down 2, left 1. And now we have to decide what type of line do we need. If y is going to be greater than,
Solid.
there we go. So we got greater than. So greater than or equal to means what type of line? Solid. All right. Make a solid line.
Either way, it's going to be a solid line.
Yeah, either way it's going to be a solid line. You got it. And now, if we use the greater than symbol, where are we going to shade? I know. But for us, where we're going to shade where for greater than? Above. We always want to go above or below. So where it's the y-axis, it means it's going to be up. So, up here, I'm now going to shade this one left and right really, really lightly, everywhere up to my blue line here. And once again, my blue line's my boundary, but I shade in the whole coordinate plane.
So it may be below, right?
Yeah, you got it. All right. We have both of our inequalities graphed. So now, what's our one last step we got to do? You got shade your solution region. So it's where you have that overlapping, that crisscross pattern, where they're both shaded in. So you want to find that. Mine's here where I have the blue and the purple. And then you kind of want to outline it first, make it a little bit darker so you can see it, and then shade in that whole region that you've just outlined. I get the magic of the Mondo, so I can do this right here. Make the marker really big, so my shading happens a lot faster. So if you grab an order pair, let me do it this way, inside this area. So we got 3, and then -2 puts me on the axis. Let's do one a little bit farther. We got like -3, oh, -3, +2. That was my fault. I'm sorry, I was looking at the wrong spot. So, -3, +2. What values are in each order pair? Huh? Oh, come on, guys. You know this one's on our test. What values are in every order pair? X and Y. You got it. So if you take your inequality that you were given, your Y is less than -x + 1, and plug in those values, you can see if it works. So our Y value here is 2. So 2 is less than. It's going to be a -3 + 1. So what do 2 negatives make? Positive. So +3. What's 3 + 1? 4. So is that true? Is 2 less than 4? Yeah, so that works. And you do the same thing with your other inequality and say y is greater than or equal to 2x plus 3. And now check it. What's our y value again? 2 is greater than or equal to 2 times x is negative 3 plus 3. So now what's 2 times negative 3?
Negative 6.
Negative 6. What's negative 6 plus 3?
No, negative 3. Negative 6 plus
No,
3?
you're right. You're good. Negative 3. You're right. Negative 3. Now, as far as it goes, you got 2 is greater than or equal to negative 3. Is that true? Yeah. Now,
Does that look like it? I don't know.
so example 2. I'll try to make sure to copy these down correctly this time. So we got x minus y is less than negative 1. And x minus y is greater than 3. So double check me. Did I write them down correctly this time? Yeah, they're good. For both of these inequalities, what do we got to do this time? We have one extra step we didn't have last time.
Put them in the y.
You got it. We got to get on the y equals mx plus b form. Now, if I get them into y equals mx plus b form, who's going to stay on the left side?
The y, so your x becomes a negative.
You got to be a negative y drops down, is less than, and your positive x becomes a negative x. Very good. And we drop down our minus 1.
Yeah,
All right.
I wish you would have picked one instead of 0.
Now, what do we got to do to finish up for y? You got divided right here by negative 1. And now we're going to end up with negative 1's canceling, and y is
1x.
alright, so 2 negatives make it a positive. 2 negatives make it a positive. Well, we still are missing something here. What are we missing?
You flip the sign and divide by negative.
Very good. Awesome. We're now going to say y is going to be greater than. Why do I have to now say y is going to be greater than?
Because you flip
We flip the sign because we divided by a negative. So make yourself a little note right here.
So, and if you divide or multiply by a negative?
You got, if you multiply or divide by a negative, we have to flip the sign. So only if you multiply or divide by a negative, you have to flip the sign. So our less than now became greater than. And guys, I usually tell people to box in this answer because this is the inequality symbol we're going to look to. We're now going to use this symbol right here instead of the other one. So we got it in slope-intercept form. What's our slope going to be? 1 over 1. Where are we going to begin? 0, 1. I'll real quickly kind of sketch out my coordinate plane over top of this one. Once again, it's a little blurry. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. X, Y, we're set. Thank you so much, Ryan. Is that good for you? If you want to use it, you can keep it and use it. I'll take it at the end. Alright. Now, where are we going to begin to graph this one? 1. You got, so begin with B, 0, 1. 0, then up 1. And now our slope tells us to go where? If it's positive 1 over 1.
Up 1, right 1.
You got up 1, right 1, up 1, right 1. Now, before we can just make our line, we have to decide solid or dash. Because it's just greater than, it's going to be a dashed or dotted line, however you like to say it. So once again, however you prefer to make it dashed, you can make a solid line, then erase it, or you can just make dash marks on it. Alright? And because it's an inequality, we now also have to determine what? Where to shade. So if it's now greater than, where are we going to shade it?
Above.
Above, you got it. So above means we're going to shade up. So I'm going to go to this line right here. I'm going to shade everywhere up and down real lightly, and use that line as my boundary. There we go. So now, we have our first one graphed. Take a second, let it sink in. Second one here, we graph it in blue, and we'll have y equals x plus b. So that means who do we keep on the left? Y, so negative y. Drop down our symbol, so it's going to be greater than. And then transpose our positive x and make him a what? Negative x. Drop down our plus 3, and we're all good. Alright, last step to solve for y. You got divided by here by negative 1. And negative 1's cancel, and y is going to be less than. Very good. We flip that symbol again because we divided by another negative 1. So that symbol flips. We know negative 1 over negative 1 makes a positive 1x. 3 divided by negative 1 gives us negative 3. And we're all good. This is the new inequality we use to graph. Alrighty. So what's his slope going to be? 1 over 1. And where are we going to begin? 0, negative 3. And some of you all may realize, is there anything in common you see between the purple and blue line? Same slope. Do you all remember what same slope means? What type of lines have same slopes? Parallel. You got it. So this one should be parallel to it. So I got 0, negative 3. So 0, then down 3. 1, 2, 3. Oh, those tick marks are very ugly down that way. Then my slope's up 1, right 1. Up 1, right 1. Now, we also have to determine line type. So, if it's less than, it's going to be dashed again. And so, once again, make a dashed line however you need to. And because we flipped our symbol, this now says y is less than. So, we're going to shade below this one. So, I'm going to go down here and put everywhere below it real lightly left and right. Alright, we have one last step. What's that last step? Shade. So you got to figure out where your solution region is and shade it really dark. Where's the solution region? You got it. This one doesn't have one. It's where they overlap, where they have a shared region, and they don't have anything shared. So what should I put for this one? No solution. So you can write out no solution, or what else could we do? You got make a circle with a line through it.
Can you get 2?
So example 3. We're going to get started, help you solve it for y equals mx plus b, and then I'll let you all try your hand at graphing by yourself. So we got 2y plus x is less than 6, 3x minus y is is greater than 4. That was my fault, read it wrong. Double check me, did I copy it over correctly? After that first one, I'm a little paranoid. Yeah, alright. So we need them both to be in what form first? Slope intercept form. So y equals mx plus b for this first one is going to be a little bit different because where's my y? I know he's in the front this time. He's usually behind the x. So who's going to stay on the left? The y still stays. So what type of y stays? 2y. You keep your symbol, so drop down your less than. But now who belongs over here? X. So your plus x now becomes a negative x, and we drop down our plus 6. Now, what's the last thing we got to do to solve for y? We got to divide everybody by 2. 2, 2, 2. 2's cancel. And now y. And we were asked a great question. Because we divided by a positive 2, am I going to flip my sign? No, because it's a positive 2. We drop down our sign as is, so less than y. And we got negative x there, just like a negative 1x. Can negative 1 divided by 2 reduce? No, so it says negative 1 over 2x. And now what's 6 divided by 2? 3. Right. So we have our m, for this one was a negative 1 over 2. We have our b is 0, 3. So make our coordinate plane. We have our y-axis, our x-axis, then 5 tick marks in all directions. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now we begin with b. So 0, 3. And now our slope tells us to go down 1, right 2, down 1, right 2. And it's less than, so less than means a dashed line. Now I'm going to go ahead and write this out too, because I'm over here, we got less than, means we're going to shade below it. So dashed line and everywhere below it. So dashed line, and below means down, so I'm going to come down here and shade mine up and down. So our second inequality, we have to get it in slope intercept form as well, y equals mx plus b. So that means we're going to keep our negative y on the left, keep our symbol where he is, take our positive 3x over and make him a negative 3x, and drop down our plus 4. Alright, divide everybody up here by negative 1. You got it. I got negative 1 to cancel, and y is going to be what now? Less than, why do we put that symbol? You got to divide by negative 1, so negative 3x divided by negative 1 is positive 3x. 4 divided by negative 1 is negative 4. There's our rewritten inequality, the one we'll use. Our slope's going to be a positive 3 over 1. We're going to begin at 0, negative 4. And now, begin with b. So 0 down negative 4. This is why it's important to graph real lightly. 1, 2, 3, 4, or shade real lightly, I should say. That way we can see our points. And now 3 over 1, that sends us up 3. 1, 2, 3 over 1. Go up 3 again. 1, 2, 3 over 1. Now, because it's less than, what type of line are we going to have? Dashed, and because I'm already here, we're going to shade for it below. So, dashed line, and we're going to shade below it. So once again, this one, the line's a lot steeper, so it's a lot harder to see below it. So I always still start down, so I'm going to start down here, and then use this line as my boundary, so down. And so this one left and right, that way it's easier to see that solution region. And now we want to shade this part where we have that overlapping area a lot darker. So I'm going to outline it with my blue line here, and outline it there with the purple line, then shade in that whole spot a lot darker. There we go. And now everywhere inside that green portion is a solution. And that finishes up for our systems of inequality.